Hi, this is Tom Devries. I'm recording today from my home in Washington State. Today, I'd like to discuss some revisions that have been made to the stratigraphy and molluscan zonation of the Pliocene and Pleistocene marine deposits in the Secaucus Basin. Here's a brief review of my talk. First, I'll give a historical review of how work came to be done in the Secaucus Basin. Then I'll cover each of the lithostratigraphic units, the Pisco Formation, the Caracoles Formation, the Pongo Formation, the Totoral to Plazo, which is at the top, talk a bit about the structure of the Secaucus monocline, talk a bit about the ages of the units, and conclude with a discussion of the molluscan zonation and some suggestions for future work in that basin. In 1981, I was introduced to Christian de Maison by Vera Aleman. In October of 1983, Christian and I drove by night to Secaucus in an Efea Land Rover. The headlights gave out in Nazca. We drove the rest of the way by flashlight. A giant pothole in Palpa nearly ate us. Christian and I spent 10 days doing field work along Quebrada Secaucus and in Aguada de Lomas. We camped on the Secaucus Chacra of Carlos and Josefina Martin, the same camping site we still use today. Our field notes from those 10 days were the basis for our 1985 paper on the stratigraphy, molluscan zonation, and vertebrates of Secaucus and Aguada de Lomas. To say the least, our conclusions were preliminary. Over the course of the next 35 years, I revisited Secaucus and Aguada de Lomas several times. My most recent visit in 2018 was in collaboration with the Peruvian-funded Magnet program, with participants from Peru, Colombia, and France. With new data from the past 35 years, a new stratigraphic understanding has emerged. At left is a stratigraphic column that shows 4 lithostratigraphic units above the Pisco Formation. The Caracoles and Pongo Formations and the Totoral Tablazo are newly defined and provisionally named. The map of Quebrada Secaucus, at the right, shows the distribution of these units. Significant landmarks are the Chacra, the Secaucus Museum, and Cerro Amarillo. Note the Pan American Highway and the entrance to Secaucus at the bottom of the map. The type location of the Caracoles Formation is in Quebrada Caracoles, a tributary of Quebrada Secaucus. The unit consists of medium and fine-grained sandstone, tan and pale yellow in color, typically massive and bioturbated, with several extensive shell beds that frequently form ledges. The Caracoles Formation is separated from the underlying Pisco Formation by the angular dientes unconformity, so named for the abundant shark teeth once found on its surface. The angular unconformity shown here is found near Cerro Amarillo. Large boulders of igneous rock, like this one near Cerro Amarillo, which is in the background, often mark the contact. The unconformity extends all the way up to Quebrada Caracoles and Quebrada Pongo. The shell beds of the Caracoles Formation contain either large numbers of the epibenthic gastropod, Crepipatella, which has an unusual morphology seen today in Bahia Paracas, or large numbers of thin, small, disarticulated valves of Mulinia, such as are found today in low oxygen basins just off the coast of Lima, according to Valentin Moguillon. The Pongo Formation contrasts sharply with the underlying Caracoles Formation. It consists of poorly consolidated and unconsolidated coarse clastic sediments. That's a car near the horizon that you can use for scale. The lower Pongo 1 allosequence is usually more consolidated than the upper Pongo 2 allosequence. Here, a basal lag of stream-rounded igneous and metamorphic rock cobbles is often overlain by an accumulation of transported shells, which here are mostly dissolved. The two Pongo allosequences consist largely of rounded cobbles, gravel, coarse-grained sand, and bioclastic debris. One distinctive bed near the top of Pongo 1 has abundant valves of the concha de abanico, Argopecten purpuratus. This long view between Quebrada Pongo and Aguada de Lomas shows gravels and light-colored shell banks of Pongo 1 overlain by the more cobble-rich beds of Pongo 2. Note Diana in the red parka for scale. Like Pongo 1, the base of Pongo 2 is strewn with rounded cobbles of igneous and metamorphic rock, with gravel and bioclastic debris in between. The unconsolidated bioclastic gravel of Pongo 2 has shell banks rich in barnacles and choros mussels, choromiddlus. Behind the head wall of Aguada de Lomas, shell banks of dissolved bivalves include specimens of Uromalia and Ensis, as well as the same barnacles and choros found in other beds. The Torre Tablazo is the oldest and highest marine terrace in the Sicako Basin. It consists of gravel, cobbles, coarse sand, with locally abundant but tiny fragments of bivalves, gastropods, and barnacles. The Tablazo descends from over 300 meters in elevation east of Aguada de Lomas to 200 meters of elevation east of Sicako. The Tablazo also tilts towards the sea. The surface is covered by continental alluvial material east near the towns of Bella Union and Acari. The most distinctive feature of the Totoral Tablazo is a set of parallel cobble ridges rising several meters above the terrace surface. These are shown in green in the figure. The ridges are parallel to the modern coast. Their geometry and marine shell debris indicate that they are beach ridges, similar to those that crossed the early Pleistocene Mancra Tablazo of northern Peru, and similar to beach ridges that form today near the mouths of rivers along the coast of northern Peru. A new day and new lighting. I should say a few words here about a remarkable structural feature that extends along much of the length of Quebrada Pongo and along the entire length of Quebrada Sicako. I'm speaking of an arcuate-shaped Sicako monocline. The trace of the Sicako monocline is shown by the red dashed line in this map. The Pisco, Caracoles, Pongo, and Totoral beds dip steeply, 15 to 40 degrees east and northeast, along the trace of the monocline, with exposures at the mouth of Quebrada Pongo, shown in figure A here, and the mouth of Quebrada Sicako, shown in figure B. Prominently exposed at the mouth of Quebrada Sicako, along this monocline, are steeply dipping ash beds that have been radiometrically dated between 5.5 and 6 million years. This view across Great Quebrada Pongo shows beds of Pongo 2 and the Totoral Tablazo rising to the west. Beds in the horizon are the same as those stood on by the photographer, but 50 meters higher. This vertical offset has occurred since the early Pleistocene. The ages of the marine beds in the Sakako Basin are generally known, but still some uncertainties remain. The youngest published age for the Pisco Formation is 3.9 million years, obtained by potassium argon dating and published in 1980 by Demouzon and Bellon. But evidence supporting an older minimum age for the Pisco Formation is currently being evaluated. Ages of 5.5 to 6 million years have been obtained by argon-argon dating of ashes near the mouth of Quebrada Sakako, and strontium isotope ages of about the same age were obtained by Dana Aaron et al. Near the Sakako Museum. We're currently awaiting new ages for the Pisco and Caracoles sediments in upcoming publications. The maximum age for the Caracoles Formation is constrained by the youngest age for the Pisco Formation, with time also allowed for events related to the creation of the Dientes unconformity. The minimum age for the Caracoles Formation is constrained by the age of the marine terraces on top of the sequences, and with time allowed for the development of the Pongo allosequences. Of course, ash beds inside of the Caracoles Formation may provide directly ages for that unit. So far, no radiometric ages have been published for the Pongo allosequences, nor for the Totoral Tablazo. Not surprisingly, ashes are scarce in these high-energy shoreface and nearshore deposits. However, outcrops south of Chala offer a way to estimate the age of these units that overlie the Caracoles Formation. A thick sequence of high-energy bioclastic sandstone and coquina is deposited on steep slopes of basement crystalline rock that are exposed along switchbacks of the Pan American Highway 10 kilometers south of Chala, above Playa Huaquiaco. These bioclastic beds have an age equivalent to Pongo 1 and or Pongo 2, based on a shared species of distinctive extinct gastropod. One particular unconformity is an erosive surface interpreted to represent a transgressive event. The ravement is overlain with a unique gray-green bioclastic sandstone and conglomerate that blankets a planar surface and fills small-scale gullies and quebradas. This area south of Chala, like most of the coast between Paracas and northern Chile, has been uplifted about 200 meters during the late Pliocene and or during the Pleistocene. At Chala, the ravement surface, marked here in green, climbs more than 70 meters vertically across the uppermost reaches of the uplifted coastline. Assuming that the ravement represents a rapid glaciostatic rise of sea level and not a sudden reversal of the long-term uplift of the coast, a transgression of 70 meters or more constrains the timing of the transgression, especially considering the close association of this ravement with two other ravement surfaces of comparable vertical magnitude. three scenarios for the timing of the Wahkiaco transgressions, and thus for the age of the correlative Pongo and Totoral allosequences, are presented in this figure. Similarities between the pattern of glacial-eustatic sea level change and the Wahkiaco revenements favor scenario 3, yielding an age for the revenements of about 0.8 to 1.2 million years. These ages would thus apply to Pongo and Totoral up in the Sakako Basin as well. Alternatively, scenario 2 is a fairly decent match, suggesting that the revenement surfaces, and thus Pongo and Totoral, could be as old as about 1.2 to 1.7 million years. One goal of my continued work in the Sakako Basin has been to create an improved molluscan biostratigraphic zonation for the Sakako Basin, covering the late Miocene to the present. A haphazard collection of index taxa, necessarily chosen during my initial field season in 1983, is now replaced by a greater number of muricoid gastropods belonging to 5 evolutionary lineages listed at lower left: Acanthina, Chorus, Concolipes, Hermina spina, and Xanthochorus. Six concurrent range zones have been defined, spanning a time from about 10 million years ago to the present. Refinements of the zonation are likely as additional radiometric and isotopic ages are obtained from strata in the Sakako Basin. There's a long list of work that still remains to be done in the Sakako Basin. Here are just a few of the projects, some of which are underway. Those are marked in red, others waiting to be done. Knowing the age of the Caracoles and Pongo formations will be important for establishing the timing of biogeographic and paleoceanographic events affecting the Sakako Basin. Those efforts are already underway. Since Christian de Mauzon's work in the late 70s in the Sakako Basin, work has been ongoing in studying the vertebrates of the Sakako Basin and understanding their ecology and biogeographic connections outside of the basin. Similar work is underway, but not published yet, concerning the invertebrates, mostly the mollusks of the Sakako Basin. An important study that remains to be started is to look at the role of structural deformation related to the Sakako monocline and its impact on facies distribution of the Caracoles and Pongo formations. There does seem to be a role played by this in sedimentary structural deformation. And the Sakako Basin is well positioned to mark or record paleoceanographic changes in the southeastern Pacific Ocean. We have one example of that record right here, a sample, a fragment of a gastropod from the Panamint province north of Paita that nonetheless found its way into Middle Pleistocene deposits in Sakako, probably arriving there as a larvae during an El Nino in Middle Pleistocene time. Well, that's it for this video talk. I'd like to thank you for your attention. Thanks to the many, many people who I've worked with and have helped me since 1980 in northern Peru and then later in the Pisco and Sakako basins. I'd like to thank Rolando Cruzado for having put together this conference. If you have any questions, feel free to email me. My email address is in the lower right-hand corner. So, thank you.